Hello, I'm John Kowalski, President of Safety Performance, LLC. I'm here today to talk to you about how safety performance tools and defenses can reduce the exposure to hazards and prevent events. This slide, you look at this slide, you think, what's going on here? How many people are involved in this endeavor, you think? Can you count how many people are there? I count one on a fork truck, one on the forks above, about 3 or 4 above there. There's even a guy behind those boxes on the right. You see him? He's probably the supervisor or maybe even the safety guy. But they got this job done, in fact. And the plant manager congratulated them for being innovative and getting the job done. So if they got the job done successfully, will they do it again? How many violations you see here? Plenty, right? People take shortcuts to get the job done. And they were rewarded for getting the job done. So they'll probably do the same thing again until something bad happens, then we'll start all over again. My company, Safety Performance, this is a model I put together with 5 key essential elements. It's got to be management sponsored and leadership driven. Everyone wants excellent safety results, but how do you get them? It's with management sponsorship and leadership driven. It all starts with leadership beliefs, leadership values, leadership policies, and how that leadership is aligned with the supervisors. Are the supervisors trained to be supervisors? Do they have the trust of the management to do the right thing? Do they have the trust of the workers? Do the workers align with the supervisor? Are workers trained how to use human performance tools or safety performance tools, I call them? Are they trained on how to do a job briefing? How to do a safety pause, good situational awareness, to follow procedures and policies? Are they trained on how to do a post-job brief? Are they recognized for doing the right thing at the right time? These 3 behaviors, management, supervisor, and workers, have to be aligned in order to be successful and have a good, successful safety program. Then you need simple procedures and policies. People need to know, have written down what it takes to be safe and successful on this job. What are the hazards involved? What are the risks I need to take? Then lastly, they need to be trained. The whole team needs to be trained on how do we be successful as a team to do the job right the first time. Hey, who are the experts when it comes to human performance? I've got 4 people that you should consider referencing and reading as well. The first one would be James Reason, Understanding the Organizational Causes of Accidents. An easy read, but it's a must read for human performance, people interested in human performance fundamentals and tools. The second one is highly recommended, Sidney Decker's Field Guide to Understanding Human Error. This is a well-written book. I met Sidney Decker. He's quite a guy. He was a pilot, and he wrote it from a pilot perspective. I'll never forget some of his presentations. They helped me be who I am today. The last 2 are The Psychology of Safety by E. Scott Geller. It's very real and practical on how to coach people and get their participation. And Edgar Schein, he's the leader in organizational development. All right. One thing Sidney said, and I'll never forget, and I want you to think about this too. When something bad happens out there, Sidney would ask, why did it make perfectly good sense for the people involved to do what they did at the time of the event? If you can answer that question during your investigation, you will get very close to the root cause. The second question I'll to ask as well is, if you took 4 other people that weren't involved with this accident, would they have done the same thing the other people would have done given the same circumstances? If 4 other people would have done the same thing the first person did at the time of the event, then what do you have? You've got an organizational issue and not an individual issue. Why did it make perfectly good sense for people to do what they did at the time of the event? How do we make sure the mental aspects of the job are driven into a person's head, their mind, before they touch the switch. First, you have to understand human performance fundamentals. The first one you must understand is people are human. The average person, according to some NASA studies, make between 4 to 7 errors an hour. My wife tells me I'm above average. I make errors. There's no one that's perfect except, amen, okay? We are error-producing machines. We need to understand that first, because even the best will make human errors. The second fundamental is that error-likely situations are predictable. We got it down to at least 4 common error precursors, which I'll talk about later. Time pressure, distractions, interruptions, assumptions, and inaccurate perception of risk. Those 4, which I'll talk about later. It's predictable that when you're in one of those error traps, your chance of error can double. Okay. Third thing is that errors and exposures to hazards can be reduced if we get mentally engaged and use the safety performance or human performance tools to reduce the amount of errors, not prevent them, people are human, to reduce errors and the exposure to hazards. Okay. The fourth thing is that behaviors are influenced by what we encourage and reinforce every day, what we tell people, how we react to their behaviors. What we encourage and reinforce every day really affects their performance, as well as the programs, processes, and procedures that we give them to use. The job site conditions. What's the job look like? Is it clean? People don't want to work in a dirty environment. They want to work in a clean environment. So job site conditions really affect the behaviors of human beings on the job. And the fifth being that events are eliminated if we understand why they occurred and have a good defense in place to prevent the event. Having one good defense in place, because I told you, people make errors, even the best make mistakes, but when I make that error, if I had one solid defense in place, then that error won't lead to a consequential event. This is an anatomy of event which was put together after 3 Mile Island accident sometime in the 90s. It was put together by the Institute of Nuclear Power Operation. And what you see here is how an event happens, really. And if you look at this chart, we looked at it for 100 or so accidents, and we found that 25%, around that amount, were due to the individual behaviors on the right-hand side of this chart. The other 75% were due to problems on the left-hand side with management, latent organizational weaknesses and defenses. So it just wasn't the individual making an error, it's how their behaviors were driven to make that error. If you look at this, you got the individual on the right-hand side. He's got human performance tools. He's got the error traps. Remember I said time pressure, inaccurate risk perception, distractions, interruptions, assumptions, influencing his behavior. He's got his hand on the machine or the part, okay? And you see that one hole in that solid block of defenses where the error makes its way to the event. Remember I said you need at least one defense in place. So when Charlie or Mary makes that error, it won't make it through the block wall to result in the event. Above that, you see defenses. Remember I talked about defenses, having defenses in place to prevent events. Those administrative controls, lockout, tagout procedures, those safety procedures, those checklists that we use. You've got supervisor controls. You've got you got engineering controls, guards, hard controls that prevent exposure to the individual of the hazard. And you've got oversight controls. Those are the supervisors and the people next to you that help you not to make that error. And on the far left-hand side, you got the organizational programs and processes. Are they simple? Do people understand the rules? Does management align with supervisors? That alignment again, to make sure that we get zero consequential events. This slide was adapted from the generic modeling system used by James Reason. And if you look at it, you see familiarity on the x-axis and attention on the y-axis. Low familiarity, low attention, and you get knowledge-based errors. Knowledge-based errors means you might not know. So if you're in a knowledge-based zone, if you know you're in a knowledge-based zone, stop and seek help. Ask somebody, is this the right thing to do? Did you do this before? Help me get there. Ask a question. How do I get there? Pull out the instructions. What's it say? What are the rules? Knowledge-based zone. Your chance of error is 50-50. You don't know, you don't go. It's as simple as that. Rule-based errors. People that write procedures sometimes don't write them correctly. So a lot of times you're looking at the box figuring out how do I put this together? Procedure says this, the box looks like that. So you got to have an alignment that's well there. But your chance of error in rule-based zone is 1 in 1,000 because it could be misinterpreted or not written correctly. So you're 99.999% successful. But if you follow procedure and if they're written right, you're successful. You're 99.999% successful, okay? Skill-based errors on the right-hand side. We talked about skill of the craft. That's the way it's done around here. And you give it high familiarity and sometimes low attention. Skills like tying your shoe. Skill-based errors. I've done it a million times before. Don't tell me what to do. I know what to do. You're 99.9999% successful until that one time you don't look right, you don't look left, and you pull into traffic and you're hit by another car. Skill-based errors. We'll talk about possible corrective actions for errors and violations. Okay, I told you about skill-based errors, rule-based errors, knowledge-based errors, and today we're going to talk about violations too. Those violations that really aren't skill-based, rule-based, or knowledge-based, but things we do to avoid the rules sometimes. So we'll talk about inadvertent actions, those skill-based errors that we forget sometimes. I call it a mental fart, but I don't know if you want to use that or not. Attention to detail. Your memory's forgetting. Your memory's going. The older you get, you start losing memory. You forget things, you know. And so your inattention, it's called. You're 99.999% successful in skill-based errors. I talked to you about inattention. So what do you do? What's your corrective action? Your corrective action in this case would be to self and peer check. Have someone check your work, okay? You can train yourself to do that. You can improve the human factors part of it, you know. You can color code it as well. So you can do things to help skill-based errors. Here's a rule-based errors, like the chance of error is 99.99% successful. You've got an unclear rule. It's not strong enough, or you got multiple rules, which makes it really difficult to follow the rule. What you can do in this case is write a better procedure. You could simplify the procedure, identify what the most important steps are in a procedure, so you make sure those steps are those critical steps that can cause something bad to happen are followed through. Knowledge-based errors, your 50-50 chance of being successful, inaccurate. You're not sure, question it. I don't know if it's the right thing to do. I get that gut feeling it might not be right. What you can do there is coach, ask for a peer check, get help, don't know, don't go kind of thing. Then violations. I haven't really talked about those yet, but violations are key to it too. You've got different types of violations. I listed 4 here. Routine violations, where I always do it that way. I always float through that stop sign, okay? I thought you were supposed to do it that way. The book says, you know what the book says about a stop sign? You stop at the stop sign, and it's effective when the wheels stop moving. That's when you actually come to a stop. The wheels stop moving. How many people really come to that complete stop at a stop sign? It's a violation. Okay, you got the exceptional violations. Well, It's 2 o'clock in the morning. No one's around. I don't see any cars. I'll just go through this red light. I'll make a left. No one's going to see me. I'm just going to do it. Exceptional. I'm late. I got to do it now. Okay? Exceptional violation. You have a optimizing violation. Man, I got to get there. I got to get there. So I'm gonna increase the speed limit a little bit here. I'm not going to go 55. I'm going to go 85. I'll optimize my performance so I get the job done right. A violation as well. And you could end up with some paper to fall on that one, maybe a speeding ticket. Or a deliberate disregard. I don't care what the rules say. This is the way it's done. So you violate all the rules, like all the rules, like the guys in the beginning with the forklift truck, the 8 guys or 7 guys lifting that load. Violating a lot of rules. I don't care what the rules say. I got it done. And the boss recognized me for getting the job violating the rules. Bad place to be. So what do you do there? How do you fix that kind of stuff? You coach, and sometimes you counsel. It's 5% of the time people only respond to discipline. You've got to give discipline sometimes. You got to take a day off from work. You got to get a cut in pay, maybe even let go if you deliberately want to not follow rules. It's something that needs to be done to protect the person, the people, the plant, and your equipment. So is 99.99% acceptable? Can you accept 22,000 checks deducted from the wrong account? Can you accept 5 airplane landings unsafe at Pittsburgh Airport or any airport a day? Can you accept 500 incorrect surgeries? Can you accept 20,000 pieces of mail incorrectly delivered due to skill-based errors or rule-based errors? People just forgetting to do what they're supposed to do. So I mentioned there were 4 common error traps. Time pressure, either real or self-imposed. Most time it's self-imposed. I got to get her done. Distractions, being distracted while you're doing something. Sometimes it's not the distraction as much as it is the interruption. Assumptions, assuming something. When you make assumptions about something, you're really in a knowledge-based zone where your chance of error is 50-50. There's finally inaccurate risk perception. This is a very important one. In my career, I've seen this a lot of times. Mainly in men. Women are more risk averse than men, but we take chances sometimes we shouldn't take. What part of the get her done don't you understand? Get her done and get her done now. Putting that time pressure on someone can lead to human error. Here's a lady working in some kind of a distribution station. Watch her see working on that machine what's happening behind her. You saw the gate open, the hatch open. She's gone. She was seriously injured during this event. What could have prevented this? Think about what could have reduced the risk. Maybe the guy gently tapping on her shoulder saying, hey, watch your step, or maybe him closing the door after he opened it to make sure that didn't happen. And the other question I have is, why would you design or have a building like that with an opening right behind the cash register? Or maybe it was redesigned, I don't know. But things like this, we got to think about what we're doing before something bad like this would happen. What are the basic safety hazards? I had a client once ask me that question. I did some research and I came up with these 8 basic things. Working from heights, falls from 4 feet or more could cause serious injury. Spills on the floor, water on the floor, oil on the floor can cause serious injury. Caught by or caught in between something is something very serious, like an automobile, or caught between 2 vehicles, or between objects somehow with machinery, unguarded machinery, tools, having that guard in place and using that guard to make sure you're not exposed to that hazard. A hard guard, I call it. Overexertion, lifting too much. The average person should be able to lift 50 pounds, I would say. Women maybe a little less, maybe a little more, I don't know. But the average person lifts at least 50 pounds. And if you got something heavy, Get help. Don't risk it. Ergonomics, things like carpal tunnel, knowing the hazards and the risks to those hazards, and unseen things like electricity, chemicals, and things that can give off energy and cause harm to the individual. Here's little John here in this photo. Does he really know what the hazard is? He's about to find out the hard way, which I did a long time ago. But what are things we can do to really protect John from these hazards, little John? We can put a hard barrier, something like a cap, on the switch, like that. There you go. You know, kids all the time, they always want to try to get them off. You have to use this key provided by the manufacturer. You turn it 90 degrees and you pull on it to get it out. You protected them with a hard defense against the hazard. So what are the hazards and the risks? Hazards are everywhere. You see in this slide, you see water on the floor, you see tools on the floor, you see clutter on the floor. Hazards are everywhere. You can either eliminate the hazard or work with it knowing the risks, like pumping gasoline in your car. You need the gasoline, which is hazardous, but you respect the risk by doing certain things at the station to make sure it doesn't involve in a fire, an explosion. Know the hazard and respect the risk. This guy in this film here, this guy in this picture here, I don't think he respects the risk enough, you know, having started a chainsaw with it between your legs. But I will tell you that sometimes people make poor choices. They fail to identify the risks of their actions. There's a real risk, as we see on this picture. The real risk never changes. It's always there. Then there's the perceived risk. Sometimes the perceived risk tends to drift, especially as we get older. We've done it that way a million times, like driving a car. I've always driven at 65. No one's ever pulled me over. I never wear my seatbelt. Nothing's ever happened until something does happen, and the perceived risk catches up with you, ends up with something bad happening. We end up with a consequential event. You've got to respect the risk, no matter what it is. There's the hazards on the right-hand side, the 8 hazards I talked about, the risk in the middle, and the people on the left-hand side. Respect the risk, the exposure to the hazard. The exposure to the hazard increased the potential for injury. Know the risk. We know the hazard's there, but really understand what the risks are. Safety improves when risk is either eliminated, reduced, or controlled with safety performance tools and defenses. You got to put the hazard in motion, and you do that with energy. It could be gravity, your step, it could be kinetic potential, it could be thermal, it could be electricity, it could be chemical. The energy puts the hazard in motion to cause something bad to happen. It could be almost certain, could be likely, could never happen, but you got to know what the likelihood of exposure is. The consequence, it could be a significant event, a fatality, or it could be a minor event, or something in between. And the risk level. Is it a high risk, red risk? Is it yellow risk? Is it green risk? Low risk activity. Every job we take involves some level of risk. Here's a chart I put together. Say there's never no risk. There are hazards everywhere, and low risk doesn't equal no risk. I've seen that in my lifetime. People doing low risk jobs end up with the worst consequence you wouldn't believe. Low risk does not mean no risk. There's risk with everything we do. Don Kahneman, in his book Thinking Slow and Fast, describes 2 systems. The first system being fast, automatic, and emotional. 2 plus 2, 4. 4 plus 4, 8. Okay? Fast, automatic, and emotional. System 1 people you really have to watch out for because they could take a risk without really thinking about their behavior and their actions. System 2 people are more slow and deliberate, the type B behaviors, thinking things through. These are the kind of leaders we need and workers that we need. Take a few seconds to think the thing through before taking the action. This is a typical hierarchy of controls, of hazard controls we've seen from NIOSH through the years. starting with the elimination, substitution, engineering controls, admin controls, and the last being protective equipment. I will submit to you in the next slide, you could add to this the human performance tools will help us reduce the exposure to hazards. Here's the Swiss cheese model by James Reason that I adopted here. You can see his model got pieces of cheese. Some of the cheeses have many holes, some have smaller holes, some are bigger holes. These are defenses to prevent a consequential event. On the bottom we see the culture, the hard controls. We see elimination, substitution, the engineering controls, putting that hard barrier up to prevent little Johnny from being electrocuted or receiving electrical shock. Then we have isolations and guards, admin controls, oversight controls, supervision, team behaviors, and the individual behaviors, PPE. As we move up, we've got indirect controls, soft controls. As we move down, we see more hard, direct controls. On the right-hand side, I've got the human safety performance tools that I call, pre-job brief, take a minute for safety, pause for safety, having good situational awareness, self and peer checking, knowing and following the rules. Those are the things that help, those pieces of cheese really help us before the event takes place. Hard controls. I call them direct hard controls. These are physical controls, like the guy rail up there, to prevent the car from going over the embankment and down the hill. Hard physical controls, probably the most effective in eliminating consequential events. Below we've got soft and direct controls. The supervisor coaching the operator, using a procedure to reduce the exposure to hazards and get the job done the right way the first time. Here's another way to express this. I've done this in my risk certification class for ASSE. I had to submit a paper, and I submitted that the human performance tools or safety performance tools are one way of reducing the risk to hazards with indirect controls, as well as hard hats and things like that. PPE, team behaviors, oversight, admin controls, and warnings. These are indirect controls to reduce the exposure to hazards. On the far right-hand side, I have the percent of reduction based on what tool's being used. And I have an example for you later. Up above, we have the direct controls, those things that really eliminate, substitute, or prevent the hazard from reaching the individual and having zero exposure to that hazard. Once I was doing a safety orientation for some construction workers, and I held this up, and I said, how many guys, I asked the question, how many guys or ladies were injured by one of these? 8 out of 10 hands went up. Almost everyone's been injured using something like this, using a grinder, portable grinder. I found in one plant I was at, every mechanic had his own grinder in his toolbox. Some of them had the wrong wheel on the grinders. Some of them had tape over the switch here, so he can use it one-handed versus holding the safety lock down, taking the safety lock out of control. So the risk of grinders, I would say, based on my experience, that you could have a serious accident. So I said, using a portable grinder to cut pipe, which was an event that I investigated, the likelihood was occasional, a 9, and the consequence could be actually recordable. I had one guy get several sutures over his thigh because the grinder kicked back. For a yellow risk level, 27. That would put you to 27 on this chart, which is toward the middle to the upper part. Safety performance tools, pre-job brief, safety pause, self and peer checks, and understanding and following the rules with effective communication and stop within certain help us reduce the exposure to the hazards. Identifying these tools help us identify the hazard, assess the risk, and provide mitigation consequences. Job briefs first came to light in the electrical power industry in 1995, where the federal government said that the 269 OSHA standard, the work party leader at every job shall understand the risk, discuss the risk control, discuss the work procedures involved, any special precautions, energy source controls, personal protective equipment, and later we have the environment. Discuss these 6 aspects before every job. They're most effective if the lead worker or the worker does the pre-job brief, so you get that buy-in and understanding of the worker of the consequences of action. Post-job briefing, taking some time after the job, either late in the day, before you hit the showers, or maybe the next day, early morning. Ask yourself, what worked well? What can we improve? Were there any lessons learned we need to jot down here so the next crew has that when they do their pre-job briefing? Here's an example of a pre-job briefing sheet I got from a company, a metal manufacturing company. They called it a pre-job risk assessment, which I thought was pretty cool, a pre-job risk assessment. Not only did they have the pre-job brief, but they had the post-job brief on the far right-hand side, asking things like, is the work site cleaned up? Was the status of the job communicated? What worked well and what can we improve on? Rule-based errors I talked about, knowing and following the rules is very important. Don't know, don't go. Knowledge-based errors, you got to know what the rules are. This guy here has got his procedure out, he's got his protective equipment on, he's got his hard hat on, he's even wearing gloves while he's going through the procedure to make sure things are done correctly the first time. There are regulatory rules, there's quite a bit of them. These are the minimal standards we need to comply by to be successful. Life-saving rules, this company I dealt with came up with a unique way. The workers came up with craft in knowing what the life-saving rules were. They said confined spaces, respecting those. Rigging and lifting, arc flash, electrical hazards, fall protection, and lockout tagout, the tagging. Here's an example of a company that put both together. And they called it their Safety and Human Performance Handbook, where they put the human performance tools, they integrate human performance into their safety handbook, because human performance is just as important as the safety rules in their handbook. It's very important that we get that alignment. Job safety analysis. Some companies don't have procedures. They're small companies, but they do have job safety analysis where they write the aspects of the job steps and the hazards involved with the job steps and the things they need to do, having the rules. In nuclear, we had these kinds of procedures. You could see on the right-hand side, guys doing placekeeping, circling each step, reading it, understanding it, completing it, then slashing the step, making sure they didn't miss one of the steps in the procedure. It's called placekeeping. Pause for safety. After your pre-job brief, you get out to the job, look at what's going on around you. Is it good to start the job? Are we prepared to do this job as we discussed at the pre-job briefing? It doesn't have to take long, just a couple minutes, if that, to what's going on before I put my hands on the equipment. Am I on the right piece of equipment? Many companies come up with these cards that they wear on lanyards to check to see that they're doing the right thing. Some call it a 2-minute drill. I have a short video to show you about 2 guys doing a 2-minute drill.
Okay, Pete, let's go through our 2-minute drill here. We're at the right equipment here. This is our 2MTC P21. It's what our work order shows.
Okay, Russ, I understand.
You agree?
This is 2MTC P21. I totally agree with you.
Okay.
Okay, let's explore the area.
Everything looks good. Looks like everything we discussed in our pre-job briefing.
I totally agree with you. We're on the right component.
We're on the right component.
The air conditions, as we discussed in the pre-job brief, look pretty much what we expected. Everything looks good.
Everything looks good.
Verify and validate. You've got to always verify and validate you're on the right piece of equipment. It could be a self-check. It could be a peer check. It could be concurrent verification. It could be independent verification. It could be correct component verification. But above all, you got to be on the right piece of equipment. You don't know how many times people have got on the wrong piece of equipment and bad things have happened. Here's a chart with all those different kinds of verifications I talked about. One thing they all have in common is the technique, the attention management technique, STAR. Stop for a second or two. Think about, point at or touch the controls. Think about the actions you're going to take. Compare it with the controlling document, then take the action, then point at and review the action taken. Stop, think, act, and review. Remember I talked about improving your attention? By using that 20 seconds, you reduce your error rate from 1 in 10,000 to 1 in 100,000. So you go from 99.9999 to 99.999. You get better. You don't eliminate the hazard, but you reduce the exposure to the hazard and you reduce the error rate. A critical step is an action or decision we make where something immediate happens, something happens that's irreversible, you can't undo it, and it ends up in a consequential event, a bad thing happening. Critical steps. You got to know what your critical steps are at the pre-job briefing, and when you do a critical step, you got to make sure you do a good self-check for 20 seconds, and someone does a good peer check for another 20 seconds to make sure that that critical step's done completely right. In procedures, we use this triangle to identify critical steps before the individual takes the action. It's immediate and reversible, much like the guy in Hawaii that pressed the wrong button to cause an evacuation. It's a gunshot. Pointing that gun and pulling that trigger, it's irreversible. Okay? Once you pull that trigger, you can't take it back. It's a critical action that you take. Critical step can cause harm to people, either through death or disabling injury. It can cause an environmental problem. It can cause an oil release or a release of gas or whatever. And it can cause an economic impact, a big loss of money. There are all kinds of steps that we do, actions that we take in a job. Some are risk important and some are critical. Not all steps are critical. Some are risk important, but some are critical. If you take that action, you get immediate, irreversible harm to people, the plant, or the environment. Okay? Critical step. Here's an example of a critical step, setting the parking brake on your truck. Three-way communication, being clear, concise, without any ambiguity. John, you get John's attention, his eyesight's there with yours. I want you to turn valve 1 alpha in the off position. John responds, Steve, you want me to turn valve 1 alpha in the off position? John, that is correct. Listen carefully to what's being said. Listen, then respond in a like manner. The task is to hook up a high-pressure hose to a suds machine. So the supervisor gets a call from home. He needs to leave work immediately. So he yells to the workers, Don, don't turn off the suds machine. What's the worker here? Don't turn off the suds machine. The next day they arrive to a very clean airplane. Coffee at McDonald's.
Large coffee with cream.
The message?
4 creams, please.
Feedback on the screen to confirm.
Okay.
The verbal
That's it.
feedback.
Large coffee, 4 cream, 106 first one in, please.
That's correct.
If fast foods can do this effectively, then we should be able to do it as well. Stop when unsure. I mentioned that you end up in a knowledge-based zone, a 50-50 chance. If you hear words like I assume, I think, I'm 99% certain, I think it goes this way. If you hear those terms, you need to stop and think about what's going on, or get that gut feeling, get some help, ask for help, make sure you know what you're doing before you do it. I have an example here.
This is Captain Hancock. You will divert your course. Over.
Negative, Captain. I'm not moving anything. Change your course. Over.
So, this is the USS Montana, the second largest vessel in the North Atlantic Fleet. You will change course 15 degrees north, or I will be forced to take measures to ensure the safety of this ship. Over.
This is the lighthouse, mate. It's your call. Hello, Captain.
Light tower. Dynamic learning activities where we show people what needs to get done, how to do things. Show me and I forget, teach me and I remember, but involve me and I learn. Came from a Zhang Kong, a philosopher, an old philosopher. A lot to be said for that. Showing people how to wear a harness. I used to do that a lot in my safety days. These days, I show people and help people coach how to use human performance tools or safety performance tools, how to do a pre-job briefing, how to communicate effectively. Those things are just as important as putting on that protective equipment. I had one company that didn't want to be observed, workers didn't want to be observed. I said, well, let's talk safety then. Okay, we'll do that. Let's talk safety. See something? Say something. Easy as that. First, talk positive. Give the person 2 or 3 things that they did right and why it was important. I see you wear that hard hat today because if that object would have fell on your head, you could have been injured. Thank you. You did a good job. Let's see here. Hey, Steve, but I did notice that the type of gloves you use, are those the best gloves for this job? Or help me understand how this job's supposed to be done. Open-ended questions for improvement opportunities. Treating the individual with dignity and respect throughout the conversation. Behaviors are influenced by the collective behaviors of everyone at your site. Those collective behaviors end up being the culture that really defines your facility. People achieve high levels of performance based on how they're encouraged and recognized. As I started with this presentation, I will tell you that an aligned organization, management-sponsored, leadership-driven, leads to excellent safety results. It's like a cog in a wheel. You've got management, leadership of the workers. Every cog's going to be rotating properly. We need this alignment throughout our organization to get excellent safety results. Here's a picture of safety performance in action where you can see that alignment with what you do, how you observe, how your pre-job briefings, situational awareness tools, the tools that you set up, how are they working in your organization? Are they all aligned in your organization? Here's a typical example of an organization that uses such cards. Here's a paper that we put together that describes more of what I talked about. And with that, I'm ready for questions. I'd like to give special thanks to Adam Paul for producing this film and the fire department for letting us use their facility to make it. Thank you. God bless.